So I'm going to talk with you today about some project that I was working on that allows you to create universal tests, allows you to walk the application and take snapshots, take images. And I'm using this partly because I want to be able to explain some of the features and functions inside of AscentialTest that allow this kind of testing to be developed. So I'm going to do a lot of demonstration and explanation using AscentialTest today, and I'm going to be pretty light on slides. And as Sandra said, if you have any questions, please save them for the end, and then we'll take them all then. But I'm going to just demonstrate what I call an app walker. And I'm going to have the app walker run through my target application taking snapshots. I'm also going to demonstrate what I'm calling a dialog box tester, which is kind of a variation of this app walker. And again, I'm doing this in part because I want to bring out some very useful Z language features, some built-in functions. And when we get to that point in the demonstration, I'll kind of summarize what I'm going to talk about using a few slides. And then I'm going to dive deep into those tests, and we're going to dissect them actually together. So let me start out by bringing up AscentialTest and running something for you. What I want you to understand is that the tests that I'm running were not built for the specific target application. Theoretically, they can be run on any application. And I tested much of what I'm about to demonstrate to you on several applications. Would it just work on your application? I don't know. It might need a few tweaks, but generally, yes. So if you're interested in any of this stuff that I'm showing you, just write to support and we'd be happy to send it to you. So I'm going to start out by running something. I call this the app walker, and I'm just going to run. And when I do that, you see that I'm testing Notepad just because it's a convenient application. And you might have noticed there was a little bit of a pause there just because it needed to collect information on the menu bar. What it's doing is it's walking the menu bar and finding any menu item that has an ellipse, the 3 dots, because then it knows it's going to throw up a dialog box or invoke a dialog box. And so it's going to go through the entire menu bar and find every dialog box that it can. And then when it's finished, I'll show you what the results look like. I think font might be the last one. Again, these pauses are because it's basically going through information that it's collecting from the menu bar. Now here's our result, and you can see that I demonstrated the app walker, and let's take a look at the results. Initially, we're just going to look at the results kind of at a high level, and then I'll be going deeper in a little while. But you can see that, I started Notepad, the application. I put some text in, so I called a step. I'll show you my test in a minute. And then I called this thing called the app walker. But the reason why I did that, because I knew in my application in Notepad, unless I put some text into this text field, most of the menus would have been grayed out or disabled, and that wouldn't be very interesting. So what I want you to notice, though, is that there's a lot of get children's going on here. If we just look through this list, it's just doing get children, get children, get children, because it wants to find out where all the dialog boxes are in the application. And again, we'll go into detail in a little while. Once it collects all the information, then it starts bringing up all of those dialog boxes. And because this is the app walker taking snapshots, you'll see that, let's see, who did I run? I ran the wrong one. I'm sorry. I'm going to run that again. I wanted to run the one taking snapshots. So let's do that. Because that one's more interesting. It's similar. It uses a lot of the same technology, but it it does some work as it's walking around the application. So we're going to see it again, and you'll notice it's opening up all the dialog boxes in the application. I only have to pass this test one parameter. The only parameter that gets passed is the app object name of the target application. So in this case, I'm telling it run against Notepad. And it's doing its thing. When it's done, I'm going to show you the test, and I'm going to show you the snapshots and the images that it took. And we'll be able to look at the date timestamps on them so we can see that they're fresh. Against this application, it takes roughly 1.5 minutes to run through the app walker taking snapshots. This takes slightly longer than the first time I ran it because this is doing a little bit of work. Okay, here we go. So this time you'll see that as it ran through, you're going to see all that same get children, get children, get children. But this time when it went through, it did some work. And so if I double click, you see that it actually took snapshots as it was running through the application. So if I want to get AscentialTest to take snapshots for me automatically for all my dialog boxes, I can do that. Saves me the trouble of having to go and take the snapshots manually. So you'll see that that's been done throughout the whole application, or all the dialog boxes that it could bring up. At the same time, it took those snapshots. It also took images. So we come here, you'll see that it captured images as well. That could be useful for you if you're using maybe AscentialTest in order to generate images so that you can write documentation for your application or training or something like that. So as I click on them, you can kind of see the images right here. And you can see from the date timestamps, those were just generated as we ran this most recent run. Let's take a look at the test itself. So if I double click on the green T, I can go in to the test, and you can see that I did call a step that set text to Notepad. That's that step that put in the whole world, the hello world. But then here's my app walker taking snapshots. So this is the most interesting step, and we're going to delve into that a little bit more deeply in a moment. Before I do that, I'm going to run something else for you. This is a variation of the app walker taking snapshots. This one, instead of taking snapshots, when it gets to a dialog box, it actually runs some universal tests that I created. So I'm going to run it now so you can see it running through. And then again, I'm going to dissect both of these in a minute. But this time, it kind of looks the same, really. It does look the same because we can't really see what it's doing. But it's doing two things. It's checking to make sure that every single dialog box that is invoked has a default button. And you can see that one does, because you can see the OK is highlighted. And if it comes across a text field, and it will on some of the dialog boxes, you will see it putting some text into the text fields because it's checking to or confirming the default max length of a text field. So it's making sure that if a field has a max length, that it's not accepting more characters than the number of characters that it should accept. I don't think I did it on all of them. I think I did it on just a couple of them to show you an example. And I'll show you how that's all configured in a little bit as well. Here's the last one, and I believe this one you might see some text go in. Yep, so you saw some text go into those text fields there. And we'll take a look at the result of this one. In fact, this one did find an error. So again, it starts out the same. It's looking for all of the dialog boxes in the application. But then it does a little bit more. It's calling some tests. So every time it opens up a dialog box, it calls the tests, the universal tests that I had put into the test plan. I'll show you where in a moment. So it looked at this dialog box and it said, well, you know what? There's no default button for save changes. So it flagged it as an error. All of the other dialog boxes in Notepad did have a default button. And then a little bit later on in the test, when it got to the font dialog box, you see that it actually put in some text into 3 of the text fields. And we'll talk about that in a couple of minutes. And it called a test called verify field length. So let's dissect these now. I'll start out by dissecting the app walker taking snapshots. We'll double click on the T. Oh, and before I do that, I want to show you, here's the test, and the only parameter that I passed it was the app name, Notepad. I passed it in as a string, but you'll see in a minute it gets converted to an app object. Some of you might not be familiar with being able to pass parameters through the test plan, because most of us use data tables to store our test data, but AscentialTest does have that feature where you can have your data directly in the plan. I could have full tables here if I want to, but again, I only needed the name of the application that I want to test. So let's take a look at this step, because this is more interesting than the first one. And I just want to get my notes up on the other screen so that I don't forget to tell you something interesting. Bear with me a minute. Okay, and I do want to actually bring up a slide. So some of the features that we're going to see as I dissect these 2 tests is we're going to see the use of try catch. Try catch allows you to handle exceptions locally. Because I'm sort of doing things, I'll say, in the dark, I don't even know the target application, necessarily that I'm running against. I could run into errors, and I don't want it to halt the execution of my test through the application. So I tended to do things in try catch. I'll show you that in a few minutes. We also, you made use of object attributes. We'll be pointing out object attributes. The reference operator. If you're not familiar with this operator, you should look it up. It's a powerful operator. It allows you to do things indirectly. I used dynamic instantiation. I used recursion. I made use of metadata. And I also had to do some typecasting. So these are some features that you may or may not be familiar with in AscentialTest, but I'm going to talk about them as I dissect those tests. I also called some built-in functions like log snapshot. That's what took those snapshots that we looked at. Parse app object. That allowed me to take the name of my target applications as a string and turned it into an app object. Get children. This is what looked at every one of those menu items to see whether or not it had submenu items. get active. That tells me what dialog box is active at any moment. Get object. We'll talk about that one in a minute. And get type. It allows you to figure out, is this a dialog box? Is this a text field? Is this a push button? We needed to know if it was a push button so we could determine whether or not it was the default push button. I also called close active windows, which some of you may be familiar with. This is a function that we wrote in support, and it allows you to close any active windows in your application. So I needed that to kind of clean up, to close anything that got left open. So those are the things, the parts of the language and functions that I'm going to go into more detail about now. So let's start with the app walker. So the first thing I want to point out is this thing called parse app object. What parse app object does, and I've got the help loaded up here, parse app object takes a delimited string. That means that you could pass it a string with dots in the string. And what it will do is it'll take apart your app object based on the dots. And so it can turn a string that has dots in it into an app object. Like, for example, if I passed it in double quotes, information.firstname, information request, I would actually get the app object, my object, information.firstname, as it was defined. So that's what parse app object will do for you. I also called something that I created here called menu item with ellipse. And if I hit the navigate button here, it'll go into it. Some of you might not know that you can do that, but you can navigate into a function. And so what this get menu items with ellipse does is it takes a look at, this is why get children was called. It keeps calling get children. And you'll notice that I call this thing recursively. So it's called get menu item with ellipse, but inside of the for loop, inside of this function, I'm calling get items with ellipse so that it's nested, so that if there's cascading menus, it'll keep going through until it reaches the bottom. That's what a recursive call will do. So I call get children up top. I get a list of children at the top level. And then I've got a for loop, and it says for each menu item in the list of menu items that got returned, go ahead and call get item with ellipse again. So if you had a menu item that had submenus, it would then go down the submenus. We'll call it recursively. If it found a menu that had an ellipse, then it had added it to this parameter called menu item with ellipse, because I wanted to find all those menu items with ellipse because I knew that those would then invoke dialog boxes. So that's why I collected that. And you see that came as an in-out parameter. So if we go back here and look, you can see that there's this parameter called menu item with ellipse. It's a variable. It's a list of app object. Starts out empty, but when it gets called in empty, and it comes out with the list of menu items that have ellipses. Then you see the for loop right here. So I'm saying for each menu item in the list of menu items. Remember, these are a list of app objects, so it's for menu item, not for string, because these are app objects. In the list of app objects, that is the menu items with ellipses, you notice the try catch here. So I'm going to try to select it. I'll put a warning up just in case, because maybe, I can put a little tweak in if it ran into a problem. So I'm not going to halt execution. I'm just going to log a warning if I had any trouble selecting the menu item. Now, this was new to me. I didn't realize in AscentialTest, and you know I've been using AscentialTest for a long time, I didn't realize that I could say top win 1, take a snapshot, or top win 1, capture an image. So I'll put this in Z for you so you can see what it looks like in Z. So well, I guess that looks pretty much the same. This one will look a little bit different, although not too different. So being able to say top win-win, I was able to get the topmost dialog box and take a snapshot of it and capture an image of it. So this turned out to be a very useful thing to do. I was thinking I was going to have to try to figure out the name of the app object, and I probably could have done that using getActive. So that would have been another way to do it, but this turned out to be pretty convenient and pretty interesting. Now, I must have run into a problem where there could be situations where Windows could have duplicate names. And so I caught that in my try-catch when I tried to do the capture image as a possible error. So I print it if that happens. Turns out I think that, excuse me, didn't end up being a problem when I had images that were stored from before. It will overwrite them, but it is possible I could get an error there, I think. And then I called that close all windows that I talked about. I'm not going to go into close all windows or close active windows in this presentation. I've done other presentations specifically on this, so you can look those up on our website or our YouTube channel if you want to learn more about close active windows. But I call it here because I wanted to close any windows that might have gotten left open here. In fact, they would have, because I didn't try to close them. I knew that close active windows would do the job for me. So I didn't have to try to figure out, well, should I hit the OK button? Should I hit the cancel button? Close active Windows already has that kind of decision-making built into it. Just going to check my notes here to see if I missed anything. Okay, I think I got everything there. Let's go back to the plan. And this time I want to dissect the dialog box tester. So we'll go into that step. Oh, and before I do, again, I want to show you that this particular test takes 2 parameters, the name of the application as a string, and then the name of the universal functions that I want to call. So these are functions that had already been written. One will confirm that a dialog box has a default push button, and the other one is going to confirm expected field lengths. So if you expect a field to only accept 8 characters, it'll raise an error if it takes 9. So let's take a look at those. And you could add as many as you want to this, because this is a list. I could click the plus sign here, and if I had other universal functions that I wanted to call, universal tests, I could just keep adding them to the list. So it's quite easy to add them. So we'll take a look. If this looks similar, well, it should, because it's mostly the same. You know, it's using the same code. I just copied it from the one that's taking the snapshots. But what's interesting about this one, there's a couple of things actually, is that this will call the universal functions that were passed in as a list of string. And you can see here in the try-catch, this is the part that's different from the step that we just looked at. For here, we do our for each menu in the menu item with ellipse. Go ahead and try to select it. When it comes up, then we're looking at all the universal functions in the list of universal functions that was passed in. For each string in the list, we're calling, using the @ operator, the function name. And Again, if we get an exception, I'm going to go ahead and log that as a warning because I don't want to halt the execution of my test. I just want to know about it, and then I'm going to close the windows. Now, let's take a look at those universal functions because those are interesting. So the first one is the confirm default push button. First thing I want to point out to you is that, so at this point we've launched a dialog box, but this function, remember what I mentioned earlier, is this function is a universal function. It doesn't know what dialog box we're testing. It doesn't really need to know ahead of time because this function, getActive, will tell us. So if you ever want to know what is the current active window, the window that's up on top, you can call ua.getActive and it will return not a string, but an app object. In this case, it's going to be a window. It's not going to be like a push button or a text field. It's going to be a window. It'll return the currently active window. And here I'm just printing this just as kind of echoing it back as confirmation. And then I'm setting that active. I'm not going to assume that it actually became active when it was invoked, so I'm going to set it active. And then I'm getting a list again. I'm getting a list of all the push buttons. Now this is interesting here because I'm using a selector. Most of us are used to using selectors on tables and things like that where we're selecting a row. But you'll recall that selectors have these keywords like first, second, last, exact. Well, all is one of them as well. And I can call a selector on the class of push button. So push button all. And then on that, what's returned, I call this thing called getObject. This is built right into AscentialTest. And so what this line is doing is that for the currently active window, it's getting a list of all of the push buttons as app objects, not as strings, but as app objects. And then I'm printing it just to echo it back to the results file so I can see it. Then we go into a loop here, and we have a Boolean, true or false, initializing it as false. So there is no default push button yet. Then another for loop. And these for each loops are very useful. I'm saying for each app object, is the variable name, in the list of app objects that was created here. This is a list of push buttons in the dialog box. If the current window dot, and I'm using the reference operator here to take the name, so I'm converting, this is important. If you ever want to get the string name of an app object, all you do is you cast it. So you put string inside of square brackets in front of an app object and you will get its name. So this is the name of the app object as a string. So now I'm concatenating that string back onto the current window, and I'm using an attribute. Every push button has an attribute called isDefault. If you look at the elements panel and the attributes panel of any of your snapshots, you can point at any of your push buttons by clicking on them in the elements panel. And you can see whether or not isDefault is set to true or false. Well, it should only be set to true for one of the push buttons in your dialog box. But a Windows standard says there should always be a default push button. And so if it's set to true, then I'm go ahead and printing it, and I'm returning because that means that this function did its job. It found a true default push button. If it didn't, well, then it's going to log an error And we did see that error in the results file. It said there was no default push button for that dialog box. So kind of a lot going on here in this very brief function. I'm just going to check my notes quickly and make sure that I told you everything I wanted to tell you. I talked about the selector all. I talked about casting to a string. I talked about the attribute is default. Now I have another universal function here that I want to talk about. Remember, there were two that were called. And this one starts out in a similar way as the one that we just previously looked at, in that it figures out at runtime what is the active dialog box, gets caught in the variable called wCurrentWindow. I print it, set it active. Excuse me. Again, similar to what I did in the last function, I'm getting all the children of the current window, and I'm printing that list. Then I say for each object in the list of children, check its type to see if it's either a text field or a combo box. Because if it's one of those types, then I could check the field length. So get type will tell you what is the type or class of the object. So if it's one of those, then I'm going to check to see whether or not this particular text field was configured with some metadata. When you see the % in AscentialTest, you probably, it's also used as modulo in math functions, but when you see it in front of an object like that, you could bet that this is a piece of metadata. And I'll show you how that's set in just a few minutes. So I'm checking to see whether or not that metadata is null or empty. If it's not, then I'm going to check the expected length. I'm going to get that out of the metadata. And then I call another step that I had written previously called verify field length. And I'm passing it the field and the expected length that I got out of the metadata. We'll have a look at that in a second. And again, it's in a try catch, so if there's an error, I just print the error, print the exception, and then I close the window. In this case, I'm not calling that universal function, I'm just calling close. I could have called close active windows if I wanted to. This is another method of doing it. You see I'm using the reference operator, because if I tried to do it without doing that, I'd get a compile error. This gets me around the compile error because it doesn't get evaluated until runtime. That's what's nice about the $. You can put something in a string and it gets evaluated at runtime, not at compile time. Pretty sure if I just tried to say wCurrentWindow.close, open, close parent, I'm pretty sure I'd get a compile error. So I'm waiting to get that evaluated until runtime, when it won't get an error. Now I just want to show you something before I forget. I want to show you this metadata. So you can create your own metadata in AscentialTest by creating a class and giving it and inheriting from the class of metadata. So I called this class field length metadata, inheriting from metadata. And my class has two members, the field length, the field name, and the expected field length. And I'll show you an example of how that's set as well. So this is where I'm defining the class, and then I'll show you where I actually used it. So if we look here at my combo boxes, got a couple of combo boxes in the font dialog. There's the font dialog. Then I've got a combo box called font, and I set that metadata. The way to set it is I say % field length metadata. So that's the name of the class. And then in square brackets, I can say field name equals font, expected length is 63. So there's the field length and the expected length. So we put them inside of square brackets. So that's the expected field length for those two fields. It shouldn't allow 64 characters. It should only allow 63 characters. And then the size field should only allow 5 characters. So this is how I'm putting the expected result into my objects so that I could then use this universal function to check whether or not the field length exceeds the field length that I'm expecting. So that's what's going on there. Now let's take a look at this step. This is a really simple step. This has been around for a long time. It starts out by setting this variable to empty, test string, and then it creates a dummy string of the expected field length, because remember, I'm passing in the name of the field and then the expected field length. So I'm creating a string of the expected field length. So replicate would then make a string of A's 63 characters long if I called it on that particular field, that combo box that was 63 characters. Then what I'm doing is I'm just adding another character onto it. So I'm exceeding it, and whoops, I didn't mean to do that. I'm exceeding it, and by putting an X on the end of it. And I'm just doing type keys. So I'm trying to type into the field. Then I get the actual text. So I'm expecting the actual text to equal my test string, not the test string. Notice I didn't add it to the variable. I just added it here in line here so that my test string could be used for verification. So here I'm making sure that the actual string that got set is equal to the test string. If it's not, then the field length was exceeded. The field allowed more characters than it was supposed to, and this would generate an error. It would be a failure. Let me just check my notes real quick. Make sure I said everything that I wanted to say. So we talked about the function to get the expected field, the length from the metadata. Yes, I believe I covered everything there. Okay. Now what I want to do, I want to show you those results again. So you might remember where I was echoing back, so here's the list of children that got echoed back. So these are all the buttons that were on the dialog boxes. Again, you can see all that echoed back. And if we look at the trace, we can also see here's that string where I replicated the A 63 times in order to generate a long string and then added the X to it. I did that in both cases. And here I just added it to the expected length of 5 to make it 6. And you notice there aren't any errors, so those all did work correctly as expected. So in this presentation, I demonstrated the app walker taking snapshots. I demonstrated the variation where we call universal functions. We looked at some Z language features and some built-in functions that made creating indirect and universal tests possible. And at this point, I want to turn it over for questions.